All right, here's your notes for section 3.1. There's going to be a lot of graphing on here, so hopefully you have a handout. That handout should have all your graphs and a lot of this information already on it, so you don't have to write this all down. We're going to plot points in a coordinate plane. Coordinate plane is a much more specific way of talking about a graph because graphs could be line graphs, bar graphs, pie graphs. They're all different types of graphs, but a coordinate plane is where you have the x-axis, the y-axis, the x-axis, the y-axis, and coordinates on there. So first we're going to get going with the terminology. It asks you to label this coordinate plane. We've got some vocabulary words here and places. We have the 4 quadrants. So in labeling them, you probably just have to write it over there. The x-axis, make sure you know that this one is the x-axis. It's going across. The y-axis is going up and down. That's the vertical one. It's going this way. Or if you want to label it y-axis like this. Okay, I always remember this, like X goes across. You know, you see those signs like deer crossing or railroad crossing or cattle crossing or whatever. They put an X to shorten it, crossing. Okay, well, if something is crossing the road, they're going straight across the road. They're not like jumping straight up high. So try to not get those goofed up. By now, I think at this point in your math career, you're pretty good at this, but just getting them backwards once or twice screws the whole thing up. The origin. Origin is 0, 0. It's the exact middle of the graph. Go ahead and throw some coordinates on that. You should have 0 and 0 for the origin. 0.0. You didn't move over, you didn't move up. It's right smack dab in the middle. All right, your quadrants. First of all, notice that all of your quadrants are in Roman numerals, 1, 2, 3, and 4. If you call this quadrant 3, it will be marked wrong. Yes, that is quadrant 3, but quadrants don't get labeled with these numbers. They get labeled with Roman numerals is the proper vocabulary. So quadrant number 1, it'd be tempting to put it just in order and put a 1 in the upper left-hand corner. But quadrant 1 is the most popular and the most used quadrant. Makes sense that you'd call that quadrant number 1. That's because all of the x values are positive, all of the y values are positive. So anytime you're graphing something like distance compared to rate, or rate compared to time, or if you want to say, here's how many gallons of gas you put in, here's how much it costs. Here's how many pizza toppings you put on your pizza, here's how much it costs. Everything that we talk about, almost everything we talk about in real life, is in the upper right-hand corner because it's all positive. That's why that's quadrant 1. Then we go around in a perfect circle, but counterclockwise, if you know your clocks. Then it goes to quadrant 2. Quadrant 3, then, keep going in a full circle. And quadrant 4, remember 4 is spelled IV, not 1, 1, 1, 1. And there are your quadrants. Those are the parts of a coordinate plane that you have to know. Which ones are the x and y axis? Where is it when we call it the origin? And then quadrants 1, 2, 3, and 4. You need to do this on your homework and on your daily quizzes, so make sure you come back, label this, and double check it on your notes before you get them wrong on future stuff. Just a reminder of the coordinates. It says give the coordinates, and when we give the coordinates, x comes first, then y. If you don't give it in parentheses and you don't put a comma in between it, also wrong. I know it's getting very detailed and specific, but that's how math is. If this is how you write a coordinate, that's how you write a coordinate. Same thing in English. If you're supposed to spell something right, spell it right. This is kind of the spelling of math. Where is point A? We'll do parentheses and a comma. Starting here at 0, we'll count the x-axis first, and we went left 1, 2, 3, 4. Left 4 is negative 4. Up 1, 2, 3. Left 4, up 3. B. Where is B? B, we're going left 1, 2, down 1, 2, 3. So not only is the x negative, but so is the y negative. And it makes sense if you're in quadrant 3. Quadrant 1 should be plus plus. Quadrant 3 should be minus minus. Where is C? C is over here at 1, 2, 3, over 3, but up 1 space. And D, make sure you put the right one first. It did not move on the x-axis. Didn't go right, didn't go left, did not move for x. So over 0, but it did go up 2 spaces. Whereas E is going from the origin over 2 spaces on the x-axis and down 1, 2, 3, 4. Because it's down 4, it's negative. All right, there's coming up with coordinates. Other way around, put these points on the graph and describe their location. Go ahead and pause the video, put A, B, and C on the graph, and label their location. All right, come back from pausing the video. A should be at -4, 4, left 4, up 4. When it says label it, you have to put an A by it. Don't put -4 and 4 by it. We already know that because it went left 4, up 4. All it needs is a capital A. B, to the right 3, down 2, gets a B. C, over 0, didn't move over at all, but went down 4 spaces, and there's C. Describe the location. That's where the vocabulary comes in up here, the first one. Where on the graph is it? Is it in quadrant 1, 2, 3, or 4? Is it at the origin? Is it on the x-axis, or is it on the y-axis? These are the locations of your graph. So when it says describe their location, we look at A. The location of A is in quadrant 2, Roman numeral 2, not 2. Can't do that. Location of B, quadrant 1, 2, 3, 4. Quadrant 4, IV. And C, some people would be tempted to say quadrant 1, 2, 3, 4, between quadrant 3 and 4, or they'll write quadrant 3 and 4. Not the case. C is on the y-axis. Because it's right on that line, the one that goes straight up and down, you actually say its location is on the y-axis. All right, next up, they want you to graph this function, y equals 2x minus 1. We talked about domain in chapter 1. Domain are all the x values, and it's very nice right now. They're giving us the domain. Soon, in the next couple sections, we're going to have to make up our own domain. Makes sense that we use a couple negative numbers so we know what's happening on that side of the graph. We should always use 0. Then we have a good picture of what's happening in the middle of the graph. And a couple of positive numbers. Notice the two negatives and the 2 positive numbers. Super small, 1 and 2. If we want to use 10 and 11, we can. If we want to use -20 and -21, we can do that too. But then our graph gets really big. 2 times 20 minus 1, we'd have to go 49 points on the graph. 39 points. So anyway, we're going to make a table every time. Here's a table. This time it's made for you. The x values are the domain. So we have -2, -1, 0, 1, and 2 in order. The equation's in the middle, 2x minus 1. And we're going to plug in the -2 is going to go in for x. Calculate that on a calculator. 2 times -2 minus 1 equals -5. We'll do it again with -1. 2 times -1 minus 1. Calculate that out. You get -3. 2 times 0 minus 1 is -1. And if you need more time, pause the video, slow it down. 2 times 1 minus 1 is 1. Last one, 2 times 2 minus 1. When you put this in your calculator, put it in all at once. 2 times 2 minus 1. Don't even need the parentheses. You can type 2 times 2 minus 1. And you get 3. Little pattern going on over here. This pattern went -5, -3, -1, 1, and 0, and 3. Will that always happen? When we're working with lines, it will. Now over here it asks us to list the ordered pair. So we're going to take -2, which is our x, and -5, which is our y. -1, our x, -3, which is our y. Go ahead and list them all. Pause it if you need to, or rewind. With parentheses, with commas, there's your 5 points. And then next it says graph the function. So you go over to the graph. Our first point, as we just practiced, was -2, -5. We're going to go left 2 and down 5. 1, 2, 3, 4, 5. Left 1, -1, down 3. 0 was -1. 1 was 1. And 2 was 3. Okay, it wanted us to graph this function, y equals 2x minus 1. It gave us a hint for the domain, but we get to put in, like I said, any numbers we wanted to. So if it asks us to graph the function, y equals 2x minus 1, it wants any number that you could possibly think of on that graph, which means this time you're going to connect and go past all of the dots and connect it with a line. That's the whole function, because we could have put in 0.5 if we wanted to. We could have put in -3 if we wanted to. And also by doing that, it's a quick check. What if you would have put one of these in the wrong spot just because you counted wrong? Maybe this dot was here. Well, when you drew your line, you could say, oh, whoops, I made a mistake. It should all be in a perfect line. All right, we're going to do the same thing with this one. Take a look at the function, though. It does have a fraction in it, -1/3 x plus 2. Take a look at this domain. I told you we don't want to use really big numbers because then it gets a lot bigger on our graph. Having a couple of negatives is good. Always knowing what's happening at the origin is good. Having a couple positives. But instead of -2 and -1, we went with bigger numbers this time. A little hint, a little foreshadowing. You're going to have to do this yourself in a section or two. But take a look at your x up here, at your number in front of your x. It's got a fraction, and that fraction has a denominator of 3. So wouldn't it be nice if all of the problems that we plugged in were divisible by 3? Because then we're not graphing any fractions. Because I know how you feel about fractions. Most of you, they freak you out. We're getting better, though. Fractions are our friends. Just repeat that. So in our domain this time, we're going to go with -6, -3, 0, 3, and 6. Always put them in order. And it's going to look like -1/3, parentheses, -6 plus 2. And over here, you're going to get a 4. Okay, pause the video and go ahead and finish this and see if it matches what I end up with. All right, when you have those done, come on back to life, take a look. Hopefully you see this repeating pattern of multiplying by negative. Because we multiplied by a negative, look at what happened to your y values in the function. They kept going down. And a nice, easy step pattern, 4 to 3 to 2 to 1 to 0. Hopefully you already made your ordered pairs, and we're going to graph it right now. Pause it if you didn't write your ordered pairs yet. And when we put those on a graph, we're going to start left 6, up 4. Be sure not to get your x's and y's back or mixed up. Left 6, up 4. 1, 2, 3, 4, 5. Yeah, it goes off the graph just a little bit. Going off by 1 is doable. 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4. Be right about here. Then we went left 3. 1, 2, 3. Up 1, 2, 3. Then we went 0, and the 0 ended up 2. And again, you can kind of start to see if you're going to make a mistake. Maybe you counted wrong. Maybe you plugged it in wrong. If it's not going in a nice straight line, you goofed up somewhere. Put that in there. Then we went over 3 and it ended up 1. And our last point was over 6, but that landed right on 0, right on the x-axis. Connect all the lines, because it said graph the function, and it just gave us a hint on the domain. I said connect the lines, didn't I? Connect the dots by making a line, straight as you can. You don't have to get out a ruler or anything. And there's your graph. That's what you'll be doing for your assignment, which is why I gave you a worksheet, because nobody wants to sit in their notebook and draw all this graph stuff, except for those few of you that do have graph paper as your notebook paper, but it's much easier to do it on a worksheet. So go back and look at these and see how to graph by making tables, and make sure you label everything properly. Good luck on 3.1.